Hi everyone, so today in this video we are going to solve this problem from CSES problem set that comes under the sliding window section and goes by the name sliding window median. Okay, so let us start with the problem now. So the problem starts like this, that you are given an array of n integers and your task is to calculate the median of each window of k elements from left to right. So here the definition of median is given. So the median is the middle element when the elements are sorted. So if the number of elements are even, then there are two possible medians, and out of them we have to assume that the median is the smaller of them. So in the input, first line contains two integers n and k, that is the number of elements and the size of the window, and then you will be given with n integers representing the array, and in the output you have to print a total of n minus k plus 1 values, that is the median value for each of the window. And here the constraints are given where k and n can go up till 2 into 10 to the power 5, and the value of each element of the array can be as high as 1e9. So these are the constraints, and here is an input given, and this is the expected output here. So this is the whole problem. I hope you got this problem. So the problem is asking us a very simple thing, that for each window of size k you have to compute its median, and if the window size is even, then there can be two possible medians. So out of those two possible medians you have to select the smaller of them, that is the left one when the elements will be sorted, right? So this is the problem here. So let us now try to understand this given input only and see how this expected output is coming. So let us move forward now. So this is the array given to you, right? So since I want to use one based indexing, so that's why here I have added a dummy value of 0 at the 0th index, so that I can represent the given array in one based like this, that is from 1 to 8th index, right? So this is the original given array from 1 to 8, and since the value of n is 8 and k is given as 3, right? So the value of k was 3 here, so that's why the total number of windows of fixed size will be equal to n minus k plus 1. 8 minus 3 plus 1, that is 6. So since there are a total of 6 windows from left to right, so here I have marked each of the window with different colors, and on top of that I have written the expected output. So this will be our very first window of size 3, right? And as you can see that the elements present in this window are 2, 4 and 3. So when this elements will be sorted, then the elements will be like 2, then 3, then 4. So in the middle 3 will be coming, so that's why the median of this window is 3. Similarly for the next window, these were the elements, that is 4 and then 3 and then 5. So when these elements will be sorted, then the elements will be like 3, then 4, then 5. So in the middle 4 will be coming, so 4 is present here. And same for the remaining windows till the last window here, that is the 6th window. So this is the given input and these are the expected outputs, right? So let us now move forward and see what logic we will apply and what concept can be used here in order to solve this problem, right? So ask yourself that what data structure can be suited here in order to solve this. So pause this video, think for a minute and then come back to it. So I hope you pause the video and try to thought about it, but if you're not able to think, then there's no problem. Let me tell you what data structure we will apply. So we will use a multiset here, but instead of using a single multiset, we will use actually two different multisets, that is a double multiset. So I hope you know what does a multiset means. So multiset is nothing but a set only, but the same value can be present multiple times. So in a normal regular set, all the values are distinct, right? But in a multiset, the same value can be present multiple times, so all the values need to be distinct. And since it is a set only, that is a ordered set, so that's why this multiset will be in ordered form, that is all the elements will be sorted, right? So there are two key properties of this multiset that you should know. First, that it is ordered, and second, that it can store the same element multiple times. So we will be using this multiset only in order to solve this problem. And as we will move forward in this video, you will understand why using this multiset is feasible in this problem, right? So how we will solve this using this multiset, so let's see that, right? So first I will be discussing a case when the window size is even because in the question it was written that when the window size will be even, then there will be two possible medians, and out of them we have to select the smaller of them, right? So first we will discuss this case, and then we will discuss the case when the window size will be odd. So for a window size of k elements, if k is even, let's say 6, so a total of 6 elements are present in the current window, right? So since I told you that we are using two different multisets here, so let us call the first multiset as the left one and the second multiset as the right one, right? And since both are multisets, so the elements inside of them will always be present in sorted order. So if the elements in the left multiset are present like this, then since they are present in sorted order, so we will assume that this will be the smallest element and this will be the largest element. Similarly for this, that this will be the smallest element and this will be the largest element. So the elements of both the multisets will always be present in sorted order. So what we will do is, since the window size is even here, which is 6, so we will try to keep the half elements of this window in this multiset and the another half in this multiset, right? So if there are total of 6 elements here, then we will try to keep the first 3 elements in this left multiset and another half, that is another remaining 3, in this second multiset, that is the right multiset. So suppose that in the present window of 6 elements, the elements were something like, let's say from 1 to 6. So 1, 2, 3, 4, 5, 6, right? So after the operation has been done on both the multisets, the elements will be something like 1, then 2, then 3, so sorted in this direction, and then we will start in this multiset from 4. So 4, then 5, then 6, then another sorted in this multiset, right? So in this way both the multisets will be sorted, and as you can see that since I have stored a 3 here, and after 3, when the half number of elements are completed for this multiset, we started another half in this multiset from its smallest, right? So 1, 2, 3, then 4, 5, 6. So what I am trying to tell you is that all the elements of this left multiset must be smaller than any element present on this right multiset. That is, the largest element of this left multiset will be smaller than the smallest element of this right multiset, so that when 3 was coming here, then we wanted to start 4 from this, like that, 4, 5, 6, because in order to compute the median, we need the current window to be sorted, right? So if the window was something like, let's say 5, then 3, then 1, then 4, then 2, then 6, so we wanted to store them in both the multisets in such a way that they will be sorted in a regular order, that is 1, 2, 3, then from here we will go directly here 4, 5, 6. So don't be worried that how we will do this. I am just telling you a rough idea that what we will be doing actually, right? And we will see an algorithm very soon that how we will accomplish this. So suppose this has been done, that is the elements, that is the half of the elements of the even window has been placed into this, and the another half has been placed into this successfully. Now since we know that the window here is an even size, so there can be two possible medians, and those two possible medians will be nothing but this element and this element. And since we know that this element is smaller than this element, then in the question it is written that out of those two median elements we have to select the smaller of them. So that's why we will select this element as our median element and we will retrieve and print it, right? So in this way this will be our answer for the current window. Got it? So let us now move forward and see what we will do in case the window is of odd size. So let us now assume that the window size is odd and it is of size 7, right? So it can be something like let's say 5, then 3, then 2, then 6, then 7, then 1, then 4. So the window can be something like this, right? So 1, 2, 3, 4, 5, 6, 7. So if the window is this, then we want its median. And in order to compute its median, this this window must be converted into sorted form like this, right? So that's why using these two multisets we are trying to come to the same idea, that is trying to arrange every element of the current window into sorted form in such a way that we can find this middle element. So here we will also do the same thing. So since here the total number of elements is odd, so what we will do, is, so out of these 7 elements here in the sorted form, we will try to keep the first 3 in this left, then these last 3 on the right, and this middle element, which is our median indeed, will also be present on the left only, right? That is, the first 4 elements here will be present on the left, and the last 3, that is the half window, will be present here on the right. So if this has been done, then it will be something like 1, then 2, then 3, then 4, and after that here 5 will start. So 5, then 6, then 7, and in this way, since 4 will be stored here, so we will directly jump to this element here and we will retrieve it, and it will give us 4. That is the median element. So this will be our whole logic using these two multisets, right? And again, any element present on the left multiset will be smaller than any element present on the right multiset. That is, the largest of left here will be smaller than the smallest of this right multiset. So I hope you got the intuition that why I am doing this and how this is helping us actually in order to calculate the median, right? So for both of the cases, if you have observed, then in order to retrieve the final median element, what we are doing, we are simply going to this left multiset's largest value, right? So in that case of even, it was our median, because out of them this one is smaller, so this became our answer. Similarly, for the odd case, we know that the extra element, that is one more element, was added on the left multiset and it is present on its top, right? So again, we are just extracting this same element only in order to find the median, right? So the median's position in both of these cases are same, that is on the top of the left multiset. But now the question is how we will make sure that the elements are stored in this left and right multiset in this order. That is, the first half will be present in the left here like this, right? And the another half will be here. And this is a problem because the elements of the window here will anytime be given you in not sorted form, right? So they will not be sorted. So first 5 is given, then 3 is given, then 2, then 6. So the elements of any window will be not sorted. So how will you determine that for each element whether you should keep that element in this multiset or this multiset? So let us now see that how we will make this sure. So let us now try to handle our very first window, and I am very sure that you will definitely understand how this will work here. So since this is our first window, so we know that we will handle the first window separately as we have done in previous problems. And in order to do that, we run an iteration from the 1 to the k, and since here the value of k is 3, so we will run a loop from 1 to k, that is 1 to 3 index, in order to handle the first window. So right now we are standing on the first element, let's say, and both of our left and right multisets are empty, right? So nothing is present. So we will see that the element's value is 2. So what we will do is we will try to keep an element first in the left multiset, and if it is allowed, then we will keep it, otherwise we will keep it in the right multiset, right? So since initially the left multiset will be empty, so we'll see that it is empty, and this is the element that we are standing at currently. So what we will do, we'll simply keep this 2 here on the left multiset because it is empty now, and after pushing it to the left multiset, 2 will be inserted to it like this. And in this way, this left multiset now consists of one element and right multiset is empty as of now. And now I will increase and move to the next index, and then I will encounter this 4. So when this 4 will be present, so now we will see that if it is allowed to keep this 4 on the left multiset or not. So we will see that this left multiset is not empty, and the element present in this left multiset here, so the largest value present in this left multiset here is 2, which is definitely smaller than this 4, right? So since this 2 is smaller than this 4, so it means that we should not keep this 4 in this because 4 is larger. So what we will do, we will keep this 4 in this right multiset like this. So after doing this, 2 will be present on the left and 4 will be present on the right. And now again we will increase the size of the window and we will reach the third index. So now the element here is 3. So now again we will try to keep it first in the left multiset, and if we are allowed to do that, then good, otherwise we will keep it in the right one. So we will compare this 3 with this 2. So first I will see that if the left set is empty or not. So the left one is not empty, and this 3 is again greater than this 2, that is this 3 is greater than the largest element present in this left multiset. So that's why it will not be possible for us to store it in the left one. So that's why we'll simply store it on the right multiset like this. So after this window has been completed, this is the status of our left multiset and this is the status of our right multiset. But since the window size is odd here, which is 3, so we know that when the elements will be present in sorted form, so we will try to keep the first two elements of that sorted form on the left side and the remaining one, that is the last one, on the right side. But here the case is opposite, that is one element is present in the left and two are present in the right. But I don't want that. I want two elements on the left and one on the right, right? So since after this 2 I want to add an element here out of these two, and after 2 the element that should be coming here out of these two should be 3, that is the one present on the bottom, that is the smallest one. So what I will do, I will call a rebalance function that will transfer this 3 from this right multiset to this left multiset like this. And after doing this, this will be my left multiset and this will be my right multiset. And now as you can see that both of these multisets are present in sorted form, that is the elements value will increasing in this direction, and every element of this left multiset is smaller than any element present on the right multiset, that is this 3 is smaller than this 4. And since we wanted the median of this window, that is 2 4 3s, so when these elements will be present in sorted order, they will be something like 2, then 3, then 4. And here it is true, as you can see that first 2 is coming, then 3 is coming, and after that the limit of this left multiset is reached here, so we are moving to the right multiset, and then here 4 is coming. So that's why this sorted form of 2 3 4 is visible here like this, right? And now if someone wants to compute the median of this window, then they will have simply to look on the left's largest element, which is this 3, which is present at the top. So we will simply print a 3 here like that. So this is how this algorithm will work. Now let us move forward and try to handle our remaining windows, right? So we will keep applying the same logic here, right? So as of now our window is this, and now since we are sliding one step more, so we have to remove the contribution of this nums of I minus k, that is 2. So in order to remove this 2, because this 2 will no longer be present in our current window, right? So it means that wherever this 2 is present, whether here or here, it must not be present in either of them, because our multisets hold only those values that are a part of our current window. But since this 2 is not a part of our current window anymore, so we will erase that. So that's why I will first check if this 2 is a part of this multiset or not. So in order to do that, I will simply compare this 2 with the largest element value present on this left multiset, which is 3 here. So since this 3 is definitely greater than this 2 and 2 has not been erased as of now, so it must mean that this 2 here is present on the left multiset and not on the right multiset, because the maximum value of the left multiset is 3 and this 2 is smaller than this 3, so it must be present somewhere below, right? So that's why we will move to the left multiset here, and then we will try to find the position of this 2 and we will simply erase that. And after erasing this 2, only 3 will remain on the left side like this, and 4 will remain on the right side. So in this way we will be removing the contribution of this nums of I minus k, and now we want to add the contribution of this 5, that is nums of I. So in order to add the contribution of this nums of I, that is 5, we will check that if we should add it on the left multiset or the right multiset, right? So if you want to add it on the left multiset, so what we will do? We will check if this 5 is smaller than the largest element of this left multiset. So since currently the largest element of this left multiset is 3, which is definitely smaller than this 5, so it means that 5 should not be present here, rather than it should be present on the right multiset. So we will transfer this 5 here into the right multiset, or insert it, and after doing that 5 will come here. And since after adding the contribution of nums of I, this is the status of both of these multisets, and as you can see clearly that one extra element has been present in the right multiset now. But since we know that for the window of 3 elements, the first 2 in sorted form should be present in this and the last one should be present in this, so that's why it means that out of these 2 elements we have to place the smaller element of them into this left one. That is, we have to call the rebalance function, which will transfer this 4 into this left multiset, and after this has been done, this 4 will come here, that is this, and here only 5 will remain. right? So in this way, this will be the status of our left multiset and then right multiset. And if you see here, then our window was 4 3 5, and when you will sort this window, then it will be something like first 3, then 4, then 5. That is 3 4 and 5, and in this 3 and 4 and 5 the middle element will be 4, and here the same thing is achieved. That is 3, then 4, and then 5, and the middle element is present on the top of this left multiset here, as you can see, right? So that's why we'll just retrieve it and print it as our answer for this window. So I hope you are getting the logic what I'm trying to do every time. So what I'm trying to do is very simple, that I am trying to sort the current window in such a form that they will be present in sorted form in this direction, like this, right? And this will always ensure that our middle element will always be present on the top of this left multiset. So this is the logic here. Let us now move to the third window, and this will be our third window. And in this, first we have to remove the contribution of this 4, right? So in order to remove the contribution of this 4, we will first check that if this 4 is present on the left part or right part. So in order to do that, we'll simply compare this 4 with the largest element value of this left. So since the largest element value is 4, so it means that this 4 is definitely less than or equal to this element. So it means that this 4 is present on this left multiset. So we will find the position of this 4 in this left multiset, which will be present here, and then we will simply erase it from here. So in this way, we will remove the contribution of this 4, and after that only 3 will remain on the left like this. And once this has been done, we will now try to add the contribution of this 8. So now we will think that whether to add this 8 on the left part or the right part. So we'll compare this 8 with the largest value of the left multiset. So we will realize that the largest value here is 3, and the element now we are trying to add is 8. So it means that 8 should not be added to this left multiset. It should only be added to the left multiset if this value was less than or equal to this 3. But since it is not, so we will add this 8 into the right multiset, and that's why 8 will be added here like this. So this is the status after adding the contribution. And again, as you can see that there is an imbalance, because when the elements will be present in sorted form, which is present as of now, that is in this the elements are present in sorted form, that is 3, and here also 5 and 8. So 3, then 5, then 8. But we want that extra one element to be present on the left's multiset top and not on the right's multiset bottom, right? So that's why we will call the rebalance function here, which will transfer this one extra smaller element on the left's top. And after doing that, 5 will come here. And now as you can see that the elements are present in sorted form, that is first 3, then 5, and then after ending here, we are moving to the right one, so 8. So 3, 5 and 8. And if you want the middle element, then we just have to look on the top of this left, which is 5. So we'll just print a 5 here, right? So you can look also in the current window that the elements present were 3, 5 and 8, which were already in sorted form, and we achieved the same thing here also, that is 3, then 5, then 8, and the median is present on the top of the left. So we just printed that. And in this way we completed our third window as well. Let us now move to the fourth window. So this is the status of my left and right multisets as of now, and now I want to so this is the status of my window as well, and now I want to remove this 3. So again, the same logic, we will check that if this 3 is present on the left or right. So we'll compare this 3 with the largest value of left, which is 5. So we will realize that this 3 is less than 5. So 3 must be present on the left multiset. So we'll find its position. I will simply erase it, and after erasing, only 5 will remain here like this, and 8 is remaining on the right side as well. And now I want to increase the contribution of this one. So now I will think whether to add this one on the left or right, but I will see that this one is less than or equal to the largest value present on the left multiset. So it means that this one must be added on the left, right? So I will add this one on the left. So 2 elements will now be present on the left, that is this one and this 5. So this will be the status of my left and right multiset after this operation. And now as you can see that this left multiset is holding one extra element, that is the middle element, like this. That is, there is no imbalance now. So it means that we do not need to call any rebalance function because the things are already balanced. And now if you want the median element, then you have to simply go to the top of this left multiset, which is 5. So we'll just print a 5 here. And also you can see that for the current window, when the elements will be present in sorted form, then they will be something like 1, then 5, then 8. So the same thing is achieved here. 1, then 5, and then 8, and the middle element is present at the top of the left. So in this way the fourth window will also be done. Now let us move to the fifth window. So this will be our fifth window, and as of now this is our current window and we want to remove this 5. So we will check if this 5 is present on the left part or the right part. So if this 5 is less than or equal to the largest value of this left, then it means that this 5 is present on the left part, so we will erase that. And since it is true here, so we will simply erase this 5 and only 1 will remain here and here 8. So this will be the status of our multisets after removing this nums of I minus k. And now I want to add the contribution of this nums of I, that is 2. So in order to add this 2, we will check that if this 2 is less than or equal to the largest value of the left multiset as of now. So since this 2 is not less than or equal to this 1, so it means that this 2 should not be added to this, rather than it should be added to the right multiset, right? So we will add this 2 here, and that's why this 2 will come here and 8 will come here like that, and 1 will remain here. And whenever we will be inserting it in the multiset, it will always rearrange itself to become sorted, right? So that's why 2 is now present here like this, and then 8 is coming. That is 2 is the smallest of this right multiset now, and 8 is the largest. But since there is an imbalance now, that is the extra element that we needed is now coming in the right multiset instead of the left one. So we will call the rebalance function, which will transfer this element into the left multiset, and that's why this 2 will come here. That is 1, then 2, and then here 8 will remain. So now as you can see that the elements are sorted, that is 1, 2, and then 8. That is 1, 2, and then 8, and the middle element 2 is coming here, that is on the top of the left. So we'll simply retrieve and print it. So here also you can see that for the current window the elements are 8, 1, 2. So in the sorted order, first 1, then 2, then 8. So the middle will be this 2, which is present here. So by now you must have got the idea what I am doing and how is it helping us in order to calculate the median, right? So let us now work for the last window. So this is our sixth and last window, and as of now our window is this, and we want to remove the contribution of this 8. So we will check whether this 8 is present on the left multiset or the right multiset. So we'll compare its value with the largest element of the left multiset first. So since this 8 is definitely not less than or equal to 2, so it means that this 8 cannot be present on the left multiset, because this left multiset only contains values less than or equal to 2. But since this element is 8, so it means that it must be present on the right multiset. So we'll simply find its position in the right multiset and we will erase it. And after erasing it, this will become empty and this left will remain as it is. And now we want to add the contribution of this nums of I, that is 1. So we'll check whether to add this 1 on the left part or the right part. So we'll compare this 1 with the largest value of the left multiset first. And since this 1 is definitely less than or equal to 2, so it means that this 1 should be present on the right multiset, or sorry, left multiset. So that's why we will insert this 1 in the left multiset, and that's why this another one will come here like this. So earlier 1 and 2 were present, and now this extra one has been added, so double 1 and then 2, and this right will remain empty as it is. And since now you can see that there is an imbalance here, although the elements are sorted in this as well as this, but there is an imbalance because we know that since this is a window size of 3 here, so the first 2 elements of the sorted form should be present here and the another last element should be present here. That is, these 2 elements should be present on the left and this element must be transferred on the right. So we will call the rebalance function and it will simply transfer these 2 into the right multiset, and after that this will be the status of my left and right multiset. And now if you see, then what we wanted these elements, that is 1 to 1, that is in the sorted form they will be like 1 then 2. So the same thing is achieved here now, that is 1 then 1 and then 2. And now if someone wants the middle element, then they simply have to go to the top of this left multiset here, that is 1. So we'll print a 1. So this is the whole logic behind this problem, right? So what we printed these integers, that is 3, then 4, then 5, then 5, then 2, then 1. So this will be our final answer that we have to print. So I hope that everything is clear now and everything is logical to you, that why it is happening and how is it helping us in order to calculate the median. So let us now move to the coding part and see how we will code this. So first we will take the inputs of this n and k, then we will take the input of the array in one-based type, right? And then here I have declared 2 multisets here as discussed, that is the left one and and the right one. So here I am handling the first window. So in order to handle the first window, I will check that if the left multiset is empty. So if it is empty, then I will keep that first element in the left multiset only without thinking anything. But if it is not empty, then I will check that if the element that I am trying to put is less than or equal to the maximum element of this left multiset. So if it is less than or equal to the maximum element of this left multiset, so it means that I have to keep this current element in the left multiset only. So I'll insert it on the left. Otherwise, I need to insert it on the right. And after doing it, we will always call the rebalance function in order to make sure that if something is imbalanced, it will be rebalanced. And after doing it for the first window, for all the elements, whatever element will be present on the top of the left multiset, it will be our median. So we'll simply print that. And now we will handle the remaining windows. So for the remaining windows, this nums of I will be my next element and this nums of I minus k will be my previous element. So first we will try to remove the contribution of this nums of I minus k, that is previous element. So in order to do that, we'll check that if this previous element is present in the left part or the right part. So we'll check if this previous element is less than or equal to the largest value of the left multiset. So if it is true, and obviously in order to do that, that is to do a left.rbegin, we must check that if it is not empty. So if it is not empty and the largest value of the left multiset here is greater than or equal to the element that we are trying to remove, so it means that this previous element must be present on the left multiset. So we'll simply erase it after finding its position, right? But if it is not true, that is it is not present in the left multiset at all, then it must be present in the right multiset. So again we will try to find its position and we will erase it from the right multiset. So in this way we will remove the contribution of this nums of I minus k. And now in order to add the contribution of nums of I, we will check that if the left multiset is empty. So if it is empty at any time, then we will simply insert it without thinking anything. But if it is not empty, then we will check if the element that we are trying to add is less than or equal to the largest value of the left multiset. So if it is true, then it means that this new element must be inserted into the left multiset because it is less than or equal to the largest value of the left multiset. So we'll insert it here like this. Otherwise we will insert it on the right. And after doing both the operations, that is adding the contribution of this next element and removing the contribution of this previous element, if there is some kind of imbalance, then in order to handle that, we will simply call this rebalance function. And after that, whatever element will be present on the top of the left multiset, it will be our median. So we'll simply print that, and we'll be doing it for all the n minus k windows here. So let us now see what will be the rebalance function looking like. So this will be our rebalance function in which I have passed this both the multisets, that is left and right. So there can only be two cases. First, when the number of elements present on the right multiset are more than the number of elements present on the left multiset, because we know that there can never be any case when the number of elements present on the right multiset should be more than the number of elements present on the left multiset. Although this left can have one more element in case the number of elements of the current window are odd, but this right can never have. So that's why if this is a case when the number of elements present on the right side are more, then what we will do, we will fetch the smallest element present on the right multiset and we will transfer it on the left multiset like this and erase it from the right side. So when I say transfer, it means that I have to insert it on the left side, and similarly at the same time I have to erase it from the right side. So in this way it is transferred from right to the left like this. And this will be the second case when the number of elements present on the left side will be more than required. So when that will be the case, then we will again try to transfer the largest element of this left to the right. So in this way we will fetch the largest element of this left multiset, and then we will insert its value into the right one like this, and after inserting it we will erase it from the left part. So in this way the largest element of the left multiset will be transferred from the left multiset to the right multiset like this. So this will be my rebalance function whose work is just to make sure that the elements number are balanced on both the sides. So this is the whole coding logic here, right? I hope you got every single line here what I just told. So yeah, thank you so much for watching this video till this point. If you really like the content and can be helpful in your upcoming interviews, so please subscribe the channel, like this video and share with your friends who need to watch this series. So yeah, this was pretty much about this video. So yeah, thank you so much for watching this video. Thank you.